Hey guys, in this video we will do an introduction to implicit differentiation. But before we do that, I need to know that you're actually watching the video, kind of like last time, but instead of blinking twice, I'd like you to put your hands together, put your middle fingers kind of crossed, spin your hands around, and then wiggle. You got to do this without laughing and without drawing attention to yourself. Okay, I'm watching, so go ahead. Okay, good. So for implicit differentiation, sounds very fancy, but you'll see it'll be obvious when you're going to use it. Okay, so here's a quick little equation here. We'll use the equation of a circle, right? X squared plus y squared equals 25, so radius would be what, 5? So if you want to just get a quick sketch, I don't know, something like that. So they could ask you, find the tangent line, whatever, when x equals 3. So when x equals 3, we're at 3, 4, or we could be at 3, negative 4, right, when x equals 3. So based on the rules we know so far, you would, solve for y. And then the hard part here is you got to deal with this plus or minus. And we've talked about this before. When you take the square root, you got to consider the plus and minus. So if I need to get the slope at 3, well, I have two possibilities. So when I go to do my derivative, I'm going to have either the positive version of 25 square root of 25 minus x squared, or the negative version. And it gets kind of annoying. If I do y prime, I get what, 1/2 25 minus x squared to the negative 1/2 times the chain rule kicker. That's one version. The other version would be negative 1/2 25 minus x squared to the negative 1/2 times negative 2x. And it's tedious and really, really annoying. And at this point you could plug in the 3 and get your slopes. So instead we're going to use a technique called implicit differentiation. So sorry, this really I guess would be down here. This is old school right here, old school. This is just using your power rule, chain rule. If I want to use my new technique, I'm going to copy the same equation, but I'm going to take the derivative right now. I'm not going to do any moving around. I'm not going to do solve for y or anything. In fact, in some cases you won't even be able to solve for y. This one wasn't too bad, but in some cases we wouldn't be able to. So if I take the derivative right now, right, if I just focus on the x squared, well, that's obviously 2x. Now here's where it gets interesting. To get the derivative of y squared, treat the y as its own thing, like we did when we did chain rule. So power rule, 2 the thing to the first, 2 the thing to the first, times the derivative of that thing. Well, what's the derivative of y with respect to x? That's literally dy dx. That's your y prime. Equals, of course, the derivative of 25 is just 0. And we can solve this for dy dx. Okay, that's just a 1. That's not a prime. In fact, normally I won't write the 1. I just was emphasizing the power rule there. So let me rewrite it one more time. So 2x plus 2y dy dx equals 0. That's what that is. And we want to solve for the dy dx. So to solve for the dy dx, I'm going to have 2y dy dx equals negative 2x. Divide both sides by the 2y, of course. So dy dx is negative, the 2's cancel, right, x over y. So to get my slopes, I need to know my x and y values. Well, I know my x and y are 3 and 4. So either my slope is negative 3/4, or my slope is 3 over negative 4, so that would be positive 3/4, which makes sense because I'm going to have two tangent lines. I've got one here, there's my positive 3/4 slope, and I've got one here, there's my negative 3/4 slope. Much easier than having to break it up like that. Okay? Alright, let's try another one. Let's see, how about x cubed plus y cubed equals 6xy. Alright, good luck solving that for y. Okay, so let's use implicit. So the derivative of x cubed, of course, is 3x squared, plus, treat this as its own thing, 3 the thing to the second, times the derivative of the thing. Again, the derivative of y is dy dx. Equals 6. And then I think I'd rather bring the 6 out for a moment and just focus on xy. You could have the 6 attached to the x or even the y, just pick one and do your product rule that way. But I'm just going to focus on the product rule for xy. So I'm going to take the derivative of x, leave the y alone. plus, leave the x alone, derivative of y. Derivative of y is dy dx. Now in this case we've got dy dx in a couple of different places, so I need to get them together. So I need to do my normal algebra stuff. Treat this as sort of your variable, if you will, even though there's technically like 3 things here. But this is the one I want to solve for. So I have, let's keep this on this side. So 3y squared dy dx. This is 6y plus 6x. Here, I'll actually write that out. 6y plus 6x dy dx, right? So I'm going to bring this part over so that all my dy dx's are together. So I'm going to subtract 6x dy dx. And on the other side, I've got the 6y still just sitting there. And then I've also got to bring the 3x squared over. So let's look at all the pieces. The 3x squared went to the right side. This stayed. The 6y stayed. And the 6x dy dx came to the left side, so that I can get all my dy dx's together. If my dy dx's are together, I can factor it out. I can factor out my dy dx, leaving me with 3y squared minus 6x equals, and this I'm not doing anything with yet, and so my dy dx is going to be 6y minus 3x squared divided by 3y squared minus 6x. And it just so happens they all have a factor of 3, just coincidence there. So that's what, 2y minus x squared over y squared minus 2x. And there's your dy dx. Okay, there's absolutely no way we could have done this problem old school. We had to use implicit for this one. Okay, I would recommend, but I'm sure some of you are wondering, oh, Mr. Miller, I don't like writing the dy dx. I'm not used to that. I would recommend it in the beginning, because you start putting y's with y primes and you start thinking it's a power instead of a prime. But eventually you get comfortable enough, there's really nothing stopping you from doing 3x squared, let's just do this line. 3x squared plus 3y squared y prime equals 6, y plus x y prime, and then solve for y prime. It's the same thing. But I just think in the beginning, until you get used to it, maybe the dy dx is a better strategy. But I'll leave it up to you. If you do it this way, I'll know what you meant. Just don't think of this as a 1. I know if we write it a little quickly, it might look like a 1. You might all of a sudden write 3y cubed, which is clearly different. Okay? All right, one last one. The last video, I didn't get a chance to do a trig one, which threw some people off. So I'm going to do a trig one with you real quick, and hopefully that will get you off and running. All right, so let's look at this example. We'll do sine of x plus y equals y squared cosine x. Okay? Totally messy. Absolutely no way to solve this for y. So we're just going to do all our rules kind of in conjunction here. So I have a sine of this thing. So derivative is cosine of that thing times the derivative of that thing. The derivative of that thing doesn't require a product rule or anything. It's just derivative of x plus derivative of y. Derivative of y, of course, is dy dx. So there's our first dy dx. Equals, by the way, this is not a product rule. I know sometimes people look at this quickly and you're like, oh, sine x plus y. But it's not sine times x plus y, it's the sine of x plus y. You can't just have sine without an angle. So the angle is represented by x plus y. So this is sine of x plus y. Alright, so on this side though, ironically, we do have a product rule, okay? We have y squared times cosine x. So derivative of y squared is 2y to the first, right? Treat this as a thing. We've done y squared already. Dy dx. Leave the cosine alone. Plus, leave the y squared alone, and derivative of cosine, which is negative sine. So there's your first line of defense, so to speak. This is your all your rules applied. Now it's just algebra, solving for dy dx. And I know it's really nasty over here because you're like, how am I supposed to get that out? Well, technically, this is just a coefficient. I can still distribute that to each piece. So this is going to be cosine x plus y plus, and I'm just going to put the dy dx in front so it's easy to spot, cosine x plus y equals, and I just take one line to recopy. So 2y dy dx times cosine minus y squared sine x. Alright, so if I want all my dy dx's together, I'm going to bring this one over here, and I'm going to bring this over there. I'll do that in one shot. So I have dy dx Knew that was going to happen eventually. Cosine x plus y minus 2y dy dx cosine x. So that's me bringing this one over. On the other side, I have a negative y squared sine x minus a cosine x plus y. And now it's just a matter of factoring this out and then dividing by the messy stuff. So I have dy dx cosine x plus y minus 2y cosine x equals this thing. I'm not going to touch that side. There's nothing I can do there. And then just divide. So dy dx equals messy numerator minus cosine x plus y over just as messy denominator cosine x plus y minus 2y cosine x. And there's no, I can't cancel those out. There's absolutely nothing else I can do here. And this is your derivative. So if they gave you the x and y value, if they gave you a point, if they said at, you know, like 0, 1, let's just say that that was really a point, you would just literally put in 0 for x and 1 for y. Okay? So when you get these derivatives, a lot of times you'll see x's and y's in your actual formula, which is fine. X and y just represent the point. So as long as you know what the point is, you can just plug them in, let the calculator do it, whatever it is, and there's your slope. Okay? Alright, I think you should be good to go. The homework is on the board, but in case you can't see it, I'll put it right there. I know it's a little hard to read, but pages 188, 189, 125, 710, 11, 13, 15, 17, 20 through 23, 25 through 27, and then 41. I will upload the even answers to Edmodo, and of course, as always, let me know if you have any questions. Okay? I'll talk to you later. Bye. Why do I always end those as if I'm like it's a phone call? You know, like I'm leaving a message or something. That's ridiculous. All right, whatever. Talk to you later. Bye.